Alrighty, so now we're going to go over a couple examples where we make a scatter plot, draw a line of fit, and get an equation for that line of fit. So here we have a table that shows the birth rates, which they show as births per 1,000 people, X years since 1960. So when X is 0, that means it's the year 1960. When X is 10, that's 1970, 1980, 1990, the year 2000, and then the year 2010. So we are going to write an equation that models the birth rate as a function of the number of years since 1960. So we start off by plotting these points on our graph, on our scatter plot graph. So 0, 35.4 would be about here, right? So 35 would be here, so 35.4 about there. So then our next one is 10, 33.6. So when X is 10, the Y value, here's 33, so 33.6 would be about there. Next one is 20 and 28.3. So here's 20, 28.3 would be right around here. Then 30, 27. So here's when X is 30, and 27 would be right here. And when X is 40, Y is 22.4. And then when X is 50, Y is 20. So then if you were, so what you'll be doing later on is you'll be making a scatter plot like this on paper. So you're going to want to make it as accurate as you can. So you want to use like the horizontal lines of, if you don't have graph paper, then you'll just use the horizontal lines of your regular paper and maybe use a ruler to sketch some light vertical lines. Then after you plot your points, then you're going to get a ruler and try to get a line that goes through the points as well as possible. You try to get as many points above the line as below the line. And then once you have your ruler sitting right, you draw that line, and then that's your line of fit. So then once you have a line of fit where you, so now if you look at this, we've got 1, 2, 3 points above the line and 1, 2, 3 points below the line. So we're pretty, our line does a pretty good job of going through these points. So then the next thing we're going to do is we're going to pick 2 points on our line. So notice that like none of our line doesn't go through any of our blue data points here. It gets really close to this one, but it doesn't actually go through it. You can see it hits the axis a little bit before it. So what we're going to do is we're going to look at this line and try to find a couple of points that we can use, right? So here's a point right here. When X is 20 on the line, the Y value looks to be about halfway between 29 and 30. So we'll take this point, 20, 29.5. And then another point we can take is right here. You see how this point, the line kind of crosses on one of these grid points? So that would be when X is 40 and Y is 23. So here we've got 2 points that are on this line. Now what we're going to do is we are going to use these 2 points to find the equation of this line. So we start off by finding the slope. Okay, so if you remember the formula for slope, I'm going to write it up here. It was y2 minus y1 divided by x2 minus x1. So we need to label our points. Okay, so our first point here, we're going to say the x value is x1 and the y value is y1. And then for our second point, the x value is x2 and the y value is y2. So then when we work to find the slope, y2 minus y1 would be 23 minus 29.5. Then x2 minus x1 would be 40 minus 20. All right. So now 23 minus 29.5. Negative 6.5. And then 40 minus 20 is 20. And now we need to divide. So we'll do negative 6.5 divided by 20. So just divide by 20. And our slope is negative 0.325. Okay, so can we interpret that slope? So the negative 3.25 means that every time 1 year goes by, the x value, so this is kind of like negative 0.325 over 1. So then if we interpret rise over run, and our run is 1, our run would be when 1 year goes by. So when 1 year goes by, the birth rate goes down by 0.325. So that's what the slope means. Every year goes by, the birth rate reduces by 0.325. The interpreting the y-intercept means, so when x is 0, that was the year 1960. So to interpret the y-intercept, we don't have the y-intercept yet to interpret. So we could only interpret the slope so far. All right, but once we have our slope, now we can use one of our points to find out the y-intercept. So I'm going to change my ink color here, and I'm going to use y equals mx plus b, but I'm going to plug in for the slope and for one of my points. So to avoid using the decimal here, I'm going to use the point x2, y2, 40 and 23. So y2 equals m times x2 plus b. So I'm going to plug in for m and x2 and y2 and then solve for b to find out my y-intercept. So y2 was 23. M is negative 0.325. X2 was 40. So I need to do 40 times negative 0.325. I got negative 0.325 here, so I'm going to do times 40. That gives me negative 13. Then to find b, I would just add 13 to each side. And I get b equals 36. So that tells me, so my y-intercept being 36 means that in 1960, when x was 0, the birth rate was 36 births per 1,000 people. Okay, and then to finish off part A, write an equation that models birth rate as a function of the number of years since 1960. So we're going to use y equals mx plus b, but we're just going to put our slope and y-intercept. So y equals negative 0.325x plus 36. That would be the equation of our line of fit. Okay, let's look at one more example. This table shows the total earnings, Y in dollars, of a food server who works X hours. Okay, these are hours and these are dollars. Okay, we want to write an equation that models the server's earnings as a function of the number of hours they work. So we're going to start off by plotting these points on our graph paper. So 0, 0, that's right here. Let me see if I get my laser pointer working. 118. So over 1 up 18. Don't want to use the laser pointer. Then I can't click. So over 1 up 18. 240. So over 2 and up 40. 362. 477. 585. And 613. So you'll be careful as you're plotting these, make sure you're as accurate as you can so that your line is as accurate as you can make it. So then all you're going to do is just kind of hold a ruler until you get a line that looks like it goes pretty much through all of them with about as many dots above as dots below. Here's the line that I got. If your line isn't exactly the same, that's fine. As long as it's close, it goes through most of the, it's like goes through the trend of the data and you have about as many points above as below. So this one right here, this point right here is kind of on the line. This one's kind of below. Then we got this one above, a little above, a little above, below by quite a bit compared to these, and then above. So we've got like 2 below and 1, 2, 3. Maybe this line should have gone a little bit higher, but this point here is kind of pulling it down. So anyway, what we want to do now is we want to find 2 points on the line that we can use to find the slope and then the y-intercept. So this one, it kind of makes sense that if you work 0 hours, you would get $0. So I'm going to actually use this data point because I know for sure that data point has to be on the line. And then the other ones, I'm just looking for a nice spot to use. This one right here might work. This would be like 3, maybe 56. If I went here, this would be 4, that looks like about halfway, so maybe 75 or 74. If I used this point right here, that would be 5, I don't know, 93 maybe. So you can pretty much pick any other one of these points on the line that you can come up. That's whichever is easiest for you to come up with to be able to read what the X and Y value are. You don't want to get real close to here. You don't want to use like 1, 19 or something, because the closer the points are, the easier it is to have a mistake on your slope. So you want to get them a little bit further apart. So we're going to use, for this example, 4, it looks like it crosses about 75. Okay, so now let's use, I'll call this, let me change ink colors here. I'll call that 0, 0, that'll be my X1 and Y1. And then 475, that'll be my X2 and Y2. So when I start working on my slope, I'll try to do that up here. Remember, it was y2 minus y1 on the top, so that would be 75 minus 0. Then x2 minus x1 on the bottom, that would be 4 minus 0. So 75 over 4 is our slope, but let's grab a calculator, and 75 divided by 4 is 18.75. So our slope is 18.75. Still want to write my pen. Okay, so that means that every hour that goes by, the pay goes up by 18.75. So the slope is basically her rate of pay. Which is 18.75 per hour. Okay, so now we know the slope, so we can find the y-intercept now. So I'm going to use y equals mx plus b. I don't want to use the 0. It seems like it would be easier to use the 0, 0. But I want to use the 475 just to show that. So I'm going to do y2 and x2. So we get 75 equals, m was 18.75 times x2, which is 4, plus b. So now 18.75 times 4. That's 75. If we subtract 75 from both sides, we're going to get that b equals 0. So the equation of our line of fit is y equals 18.75x.